Quiet. You be quiet. All right, Hallie and Kellen and Aubrey. Here's what we have. We are filling out a note card that you get to use on your test because we're at the end of the chapter. And so we're starting with this. This is the full front of your note card. This is the stuff that you need for the front. We are starting with a statement that says dogs have 4 legs. Cool. Are we ready? Okay. A conditional is always an if-then form. So if something happens, then something happens.
If it is a dog, it has 4 legs.
If it is a dog, then it has 4 legs. And I am going to paraphrase, okay? If it is a dog, then it has 4 legs. Now, we're bypassing, yes, I know some dogs get hit by cars and they only have 3 legs and some have 2 and blah, blah, blah. And we have all these sob stories of dogs that have injuries and whatever else, okay? We're just going off of the normal everyday dog has 4 legs. If it's a dog, then it has 4 legs. We are going to say that that is a true statement, okay? A conditional goes P, then Q. That's the format that a conditional statement goes in. Got it?
Wait, I forgot.
Okay, hold on.
Chapter 3.
This is it's been a long chapter. This is like the beginning of the chapter. Yeah, it's been a long chapter. Okay, the converse takes that and it.
Can you go and mark out what the P and what the Q is in there?
Oh sure. Yep. If dog, that's P. Then 4 legs, that's Q. Good question.
Like on the statement, which is
Oh sure.
what's the Q?
P, Q. Yeah. Okay, good. All right, converse. What format does converse take?
If it has 4 legs.
Q, then P.
Oh.
Right? So, if 4 legs, then dog.
No.
False, okay? Give me a, what's it called when you prove it false? So that's the C. What? A counter example. Give me a counter example. Gives me something that has 4 legs that's not a dog. A cat, sure. A tiger, a whatever other animal that you want to say, right? That has 4 legs. Okay? Counter example. Cat. What?
Because, like, dogs don't have 4 legs.
But we're saying if it has 4 legs, then it has to be a dog. That's what that statement is saying. Right. If it has 4 legs, then it must be a dog. That's not true. Okay? Now, inverse. Let's go off of symbols for inverse. Shh. What's symbols for inverse?
It's a little R.
Yeah. Put a link between these two. The first and the third one go together. Except instead of being P and Q, it is not P, not Q, right? We put the little squiggle in front, okay? So I'm going to read the conditional, but I'm going to put not in front of both pieces, right? So if what?
If not dog,
If it's not a dog,
then no legs.
then it does not have 4 legs. Okay, so the animal that I have right here in my box is not a dog. Does that mean this animal does not have 4 legs? No, that's false. It could be a cat in my box, right? Okay, so false. Counter example is a cat. Does that make sense? If it's not a dog, that doesn't mean it still can't have 4 legs, right? Okay, so that's false. All right, contrapositive goes with the converse. So put a link between these two, and that format goes
Not P, or not Q,
not Q, not P. Yeah? Not Q, not P. Okay, so I'm going to go off of the QP one. If 4 legs, then dogs. Then dog. Dogs? Dog.
If no
If
4 legs.
it does not have 4 legs.
No 4. No. Yeah.
If it does not have 4 legs, then it cannot be a dog. Is that true or false? The animal that I have in my box is an animal that does not have 4 legs. So maybe it has 2 or maybe it has 6, right? Okay? That means this animal can't be a dog.
Exactly.
True.
What animal has 2 legs?
True.
You're an animal.
I don't know.
Simon.
Yeah.
Very smart.
Monkeys.
Kind of, right? We're in the animal kingdom, aren't we?
Yeah, actually.
Aren't humans in the animal kingdom? Yeah, right?
We're on the top of the food chain.
Yeah.
We are
Sure.
Homo sapiens.
We are, yeah. Is that what we're called? Okay. Good? Yes? Happy with this? Okay, do you remember what the biconditional looks like? Biconditional is kind of shoving together these two. The conditional and the converse. So we would say, it is a dog
If and only if words.
if and only if
Oh,
it has 4 legs. Is that true or false? It's a dog if and only if it has 4 legs. That is false.
Ow.
Because there could be.
No, you can have a.
If and only if.
I was.
It's saying like, okay, if it's a dog,
It's a
then
dog.
only.
It is a
dogs
dog
have 4 legs.
if and only if it has 4 legs. So it's like if it has 4 legs, it has to be a dog. That's not true.
If it has 4 legs.
Only dog or only. 4 legs.
It can only be a dog. This is like saying it can only be a dog if it has 4 legs, right?
Only dogs have 4
Okay?
legs.
What?
Or it can only be a dog if it has 4 legs, or if it has 4 legs, it can only be a dog. Those 2 things are not completely true, so that's false. Got it? That's what the biconditional is. If and only if. Got it? Okay, next thing. Flip over to the back side. We got 2 things to write down on the back, and they are this. The law of detachment.
Hold up. Can I erase biconditional on mine? I don't want it on there.
I don't care. Yeah, get rid of it. That's fine. I don't think I have one on the test.
Detachment.
Yes.
Yes.
Oh my.
Okay, law of detachment, law of syllogism. This is what goes on the back side.
I hate it.
Okay? Law of detachment, law of syllogism. The law of syllogism is also known as the
Transverse.
transitive property, right? Transitive means transition, right? Like transitioning from one to the next. So I transitioned from, who are my people? Transitioned from Trevin to Owen and Owen to Wyatt. So I went straight from Trevin to Wyatt, right? We skipped over the Owen. That's what this is. The law of syllogism is skip Owen. If you want to write that down. We're skipping over the Owen, right?
We don't like you, Owen.
We skip Owen on the law of syllogism. Okay. Pattern. Let's do the law of syllogism because we're on it, right? Law of syllogism goes P, then Q, Q, then R. Conclusion? Or is it the third statement?
Like, oh.
Then we skip over the Owen, which is going from P to R. So here is an example of that. If you study, then you pass. We're going to assume that that is true, even if it's not.
That is false.
If you study, then you pass. If you pass, then mom is happy. Okay? If they give you that information, what's the conclusion that you can draw? If study, mom happy. Okay, that's the pattern that it goes in. Right? It has to go in that order. If they start talking about, like, then you get an A or whatever, we don't know anything about that. If study, mom happy. It goes P, Q, Q, R, P, R. That's how it goes. Okay? All right. Law of detachment goes.
Stay there.
I'm staying there. Law of detachment goes P, Q, P, Q.
What?
P, Q, P, Q. I'll use the same P and Q as before. If you study, then you pass. Okay? If you study, then you pass. Let's outline the P and the Q. What's the P part? Study. Q part? Pass. Jace has studied.
Nope.
Conclusion? Jace will pass.
False.
What are you doing right now? You're studying right now, child.
Oh, I'm-
Yeah, this is P and then Q. Yeah, I'm just saying. Okay? PQ, PQ. There you go. You think so? Okay? All right, that's how that works. Law of detachment, law of syllogism. While we are there, you guys have your review, right? Chapter 3 review in front of you. While we are on this, like, wavelength for your note card, let's go ahead and do 12, 13, 14. Do you want to try them on your own and then we will regroup and do them together? Where am I at here? Sorry, I'm making people dizzy. 12 and 13. On your chapter review. Child, you just don't have anything. You're just not prepared here.
He wasn't in here when you gave
I know. You must have,
You gave me 2.
kiddo, no, Brady
Brady probably had
has both of them. I'm pretty sure of it.
One.
No, he doesn't. He only gave me 2 when you walked by.
Okay. All
Yeah,
right.
you
Whatever.
beanie head.
I gave who to?
Redheads.
Because I said
Yeah.
that. I moved.
Oh,
Yeah.
that's why.
Yeah.
That's why Lauren
Yeah.
screwed it all up. Okay.
No, you like it.
All right. Okay, number 12.
Simon, look.
Let's do this together. Here we go.
Shaq, Eel.
This guy is already in the PQ whatever if then format. What's he called? What's that first statement called? Somebody said it? Jordan. Conditional. This is already the conditional equation, and it says we are assuming that the conditional statement is true. So if you live in San Diego, then you live in California. That is true, right? Okay, that goes, conditional goes PQ, right? Okay, converse goes
If you live
QP.
in California.
If you live in California, then you live in San Diego.
Yeah, that's false.
False. Why? Counterexample.
Because you
LA.
There could be other.
Example, you could live in LA. You could live in Sacramento. You can live in wherever else, right? That's a counterexample. Counterexample. Okay? LA. Okay, what format does the inverse take? Not P, not Q.
So
So go back to the original and put not in front of it. So if what?
if don't,
If not San Diego,
then no California.
then no California. Okay, hold on.
False.
If you don't live in San Diego, that means you cannot live in California. True or false? False. You could live in LA.
LA.
I'll do the same thing. You could live in LA. Counterexample. You don't have to live in San Diego. I know, this is the worst part of it. Okay, what's the format for contrapositive?
not you.
Not Q, not P. Okay, so go back to the converse and put not. If what?
If not Cali, then not.
If
San Diego.
not, if you don't live in California, that means you cannot live in San Diego.
That is truthful.
Well, is there?
Unless
Yeah,
there's
is there
another San
another
Diego,
San
right? We'll go
Diego?
ahead and say that there's only one San Diego. Usually it will say, then not San Diego.
It's like
Okay?
Paris, Texas.
If not California, then not San Diego. What?
Paris, Texas.
Yeah, right. There is a Paris, Texas. There is, it's very confusing for me because there is a Lawrence, Kansas, and my husband's sister
My
used
dad
to live
went
in
to
Lawrence,
college.
Kansas. So we live in Lawrence, Nebraska, and they used to live in Lawrence, Kansas. She now lives in New York. But for like 5 years, she lived in Lawrence, Kansas. It was confusing. And it's not that far away. No, it's it's like within 2 hours of Lawrence, Nebraska. It's weird.
My
Wait a
dad
minute.
went to college there.
Really? Hey, cool. Okay, if you don't live in California, then you cannot live in San Diego. True or false? True. Okay. Unless there's a San Diego otherwhere, we'll not worry about that. Okay. Good.
Oh, what's that?
Okay. We have to say whether it's valid or invalid. Okay. So if a number is divisible by 6, that sounds like P. If a number is divisible by 6, then the number is divisible by 3.
Q.
That's Q. 18 is divisible by 6. That sounds like?
True.
That's saying P again. It's just being more specific, right? It's like me saying, if you study, Jace has studied, right?
No.
Now I'm just using 18, right? Okay? I'm being more specific. So that's P, right? We're talking about being divisible by 6. That's P again. Does that mean 18 is divisible by 3?
Yeah.
That is Q. It follows PQ, PQ. That is valid. How so?
Because
It's
18
the
is divisible.
The law of
Syllogism.
detachment. The law of detachment goes PQ, PQ, right?
Yeah.
But we don't
That's so valid.
Well, if not right and valid, explain your reasoning. Because of the law of detachment. We do have to say that.
It says that.
Determine whether it's valid based on the given information.
If it's not valid, write invalid and explain your reasons. So
Oh, so we don't have to explain our reasoning if it's valid? Okay, sure.
That's not.
Whatever. 14.
That's fine.
If a pet is a rabbit, that sounds like P. Then it eats a carrot. That sounds like Q. Jenny's pet eats carrots. That sounds like
R.
Q. Jenny's pet is a rabbit.
Syllogism.
P.
Invalid.
It's invalid.
If PQ is true, does QP mean it's true? No. If her pet eats a carrot, it could be another animal that eats carrots, right? So invalid. It could be a turtle because turtles eat carrots, right? Maybe?
Syllogism.
What?
Syllogism.
No, it's not the love syllogism. It's nothing because it's got to go in that order. This was going PQQP. It doesn't work. Invalid. Yeah.
Wow. That's too far.
Okay, we'll do 15 because that's on the same one. And then we'll go back up to the beginning.
Your time.
It's my bedtime.
Okay, 15. The two conditional statements below are true. Use the law of syllogism to find a conclusion. So we're not trying to write valid or invalid. We're trying to write in conclusion. If a number is a whole number, that sounds like B. Then the number is an integer. Then it is Q. If a number is an integer, that is Q again. Right? That's Q again. Then it is a rational number, that is R. So my conclusion... No, it's valid, kiddo. We're writing a conclusion. We know it's a valid
If whole
conclusion.
number, then rational.
If whole number, we skip over the O-N, right? If whole number.
You are not low.
If whole number, then rational number,
I think we
which
should
is
stop there for
totally true.
I think you should rational.
A rational number, and you have rational and irrational. Irrationals are ones that, like, are decimals that don't stop or repeat. So like pi, or the square root of 2, or e. Those are irrational numbers. Rational numbers are any fractions or decimals that stop or repeat. So like 0.111111 repeating. That's a rational number because that's just 1/9, right? 0.1 repeating is 1/9. 0.2 repeating is 2/9. 0.3 repeating is, which is 1/3. 0.4 repeating is 4/9. 0.5 repeating is 5/9. 0.6 repeating is 6/9, which is 2/3. 7 repeating is 7/9. 8 repeating is 8/9. 9 repeating is 1. Okay, all right. I've done that to you before, maybe. Ah, ha, 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 ha.
I think we should be done for the
Okay, here's what I want you to do. Here's what I want you to do. You guys have homework.
Rather.
Yeah, you do.
That's why does he have it review his homework?
Sorry. 1 through 11. Do 1 through 11 for homework. 1 through 11 for homework. Do those. I will. Do 1 through 11 for homework. I'll go back.
1/9 as decimal does, or 9th as decimal should not exist.
What?
9th as decimal. I got it.
Wait, what about 1 through 11?
1 through 11. Yes, do 1 through 11 for homework. Okay, is that what you need? All right, I'm gonna stop the video.